How y'all doing? I'm Julian Miller, CEO of Agile Space Propulsion, and I want to tell you all a little bit about what it means to be a fast space company. So, back in the day, when aerospace, or rather the invention of flight, first came around, there was sufficient impetus for innovation that ultimately enabled the flight industry to quite literally and figuratively take off. At present, there's an analogous inflection point happening in the space industry, which is leaving a window of opportunity open for fast space companies like Agile to come in and enable the space economy to be based on things other than just data. All right, so at present, there's been a rise of new access to space. So small launch commercial vehicles that are lowering the cost of getting to orbit have completely changed the space economy. But there's still a last mile problem. Once you've gotten launched into orbit, there's still no effective means of getting from point A to point B. And the major reason for this is chemical propulsion has essentially remained unchanged since the Apollo and space shuttle programs. So Agile completely breaks that bottleneck. And the way we do it is by leveraging additive manufacturing. I'm talking 3D printing actual rocket engines for in-space propulsion. So we leverage this combination of basically the ability to rapidly design, test, and iterate to essentially get to propulsion technologies that the industry had written off as impossible. And we're able to do that with unparalleled resources. So in less time than a commercially available propulsion system could ship, we're actually able to customize and mission optimize an entire propulsion system for a spacecraft. So the way we're able to do this is we actually leverage a facility that we've been running for the last decade. We've performed over 4,000 hot fire tests of rocket engines at this facility down in Durango. So here on the western slopes of Colorado, we're actually testing rocket engines for civil, commercial, and defense space. So that whole facility was built for rapidly iterating propulsion systems. Just recently has technology gotten caught up to where we're actually able to follow through on our mission, which is making space affordable. We're actually able to undercut the market by half by leveraging this core competency of rapid iteration and testing. Plus, we're able to make substantial margins while doing so by leveraging these new, modern, effective technologies that enable us ultimately to create this new paradigm of mission-optimized propulsion systems. So what that actually means is we took our first main engine thruster from a blank sheet of paper, in practice here, from a blank sheet of paper to hot fire testing in 6 weeks. 3 weeks later, a total of 9 weeks is all it took for us to run a complete lunar lander duty cycle simulation. This is an engine that has the capacity to set down an actual lunar lander on the surface of the moon. And it only took us 9 weeks to validate that we could do that. We're currently developing another engine with NASA that's basically the steering wheel. If this is the gas pedal and brake pedal for a lunar lander, we're also working on the steering wheel for a very analogous spacecraft here. So what this actually means, again, is mission-optimized, fully custom propulsion systems in less time at a fraction of the cost than what a commercial, presently available system would cost. So, in practice, what this actually means is we make space safer for our customers. We also allow them to get to profitability sooner because they're not overpaying for what used to be the longest lead, most expensive system on a spacecraft. So Dowdy, Agile's founder, started his career working at the largest rocket company in the world out in LA before realizing just how backwards the space industry is. So he took that opportunity to branch out on his own and begin developing custom propulsion systems and testing them in our simulated vacuum chamber that we have down in Durango. Lars has worked at multiple NASA centers, has developed a number of technologies that have spaceflight heritage that have actually done time in space, including a water-based propulsion system. I'm the only one on the team that's not a rocket scientist, but I balanced basically growing my first business to multi-million-dollar revenue while still graduating the top 3 of multiple world-class degree programs before doubling down on the tech venture path to get here today. The best part about Agile is we already have traction. Our first customer is a name that everyone thinks about when they think about space. And they're not only our first customer, they're our first repeat customer. So not only are we advancing rocket engines for actual moonshots, we're also working on technologies that will enable the first samples of lunar regolith to come back to Earth since Apollo. And NASA's trusting us to do this, and we're actually leading these developments for NASA. down in Durango, again, here in the Western Slopes. So the commercial space commercial customers are also citing for Agile here. We're not just a civil space agency contractor here. There's a much broader opportunity, and one of the largest commercial companies in the world has chosen Agile as a provider. Lockheed Martin is also the largest aerospace defense prime contractor in the world, so we're also working with Lockheed to explore opportunities with both the US Air Force and the Missile Defense Agency. This is a market we know very, very well, because Dowdy is the propulsion whisperer that has essentially been entrusted by these two agencies and this prime contractor to test the majority of their propulsion systems over the course of the last decade, including the farthest reaching anti-ICBM system that currently safeguards not only the skies, but also orbit. So at present, we're in the process of kicking off 3 different pilot programs, validating the civil, commercial, and defense space markets. And the best thing here is, come October, we'll find out if some of our thrusters will be flying on the first commercial lunar landers tasked by the Commercial Lunar Payload Services Program with NASA to set back down on the surface of the moon and begin doing actual groundwork, actual prospecting to see if there's anything worthwhile bringing back. So we're more than just a one-trick pony, more than just, say, moonshot landers here. We're validating a number of multi-billion-dollar market segments with a number of prospective partners here. We're looking at over $10 million of non-dilutive funding opportunities on screen, in addition to $50 million worth of revenue opportunities stemming from the spacecraft of these pilot programs. So at present, we're looking at raising $5 million, which will enable us to speed up the development cadence that we're currently at. So we're essentially 2 weeks from design to hot fire right now. This will allow us to move a little bit quicker and begin following through on these pilot programs that we have with NASA, Lockheed Martin, as well as the Air Force. With that, I'll open up to any questions.
That's a big one to start with, right? There's got to be some questions way back.
I'll try a softball question first. It's pretty clear the rapid prototyping thing has high value. I'd love you to just talk briefly about what else is attractive to those big defense contractor folks.
Can you repeat the question, please?
And then if you could finish off by how happy are you being in bed with those guys, and are you worried?
So really happy, actually, and here's a testimonial from one of those big contractors. Essentially, Lockheed Martin, for them to roll a new system using existing contractors or suppliers, would take about a decade. We're about half to a fifth of the cost, depending on the complexity of the system, and we're able to ship those systems. Again, this is a customized, not off-the-shelf, I'm duct taping this round peg, square hole type application here. This is completely custom, mission optimized, which gets them in space sooner, because we're taking what used to be a 10-year process and shrinking that down to less than 2 years before we can actually put something in space. Once we have those modular propulsion platforms developed, it takes us very little additional resources and energy to optimize that for the next spacecraft with a slightly different mission profile. So that's the real advantage, is not only the cost savings, but the timelines, especially considering that propulsion used to be the longest lead time, most expensive system on a spacecraft before Agile.
Who else has got one?
For those of us who are not rocket scientists, 3D printing rocket thrusters just sounds insane.
Everybody catch that?
I mean, I'm sure you guys have done your homework here, but what can you say about the reliability of these in comparison to more traditional manufacturing?
So with additive manufacturing, it actually unlocks new design opportunities. So if you're using traditional manufacturing techniques, you can only drill and subtract things in certain ways. You're limited by that process. With additive, you can use freeform design techniques. So not only are we able to do unique designs, we're also just recently enabled by new materials that we're able to work with. So we use metal powders and we zap them with high energy lasers, which ultimately forge them into the pieces and the components. It's a process known as direct laser metal sintering, or DMLS. So we utilize that process in order to forge these. We've actually demonstrated metals that are known as category of refractory metals and done combustion in engines up to 2,700 degrees Fahrenheit to kind of give you a range of the temperatures that we're at, and we're going to be we'll say leveling up into higher temperature materials here shortly. So very, very capable in terms of the material properties.
Okay, this one first.
Can you clarify, as it relates to the complex asset field management of bill of materials and all that stuff, is that your asset, meaning NASA is licensing the IP and then their bill of materials of any value added, things they're putting on it are protected through some distributed database structure? Or can you clarify just how you're delivering this and what piece of the stack you're building versus what you're integrating to?
Yep, so we sell actual thrusters. So these are rocket engines for spacecraft for the purpose of getting around once you're in orbit. They're optimal for that. They can also function as, say, a kick stage for a rocket that you can put on the very upper stage to take a satellite to its end destination orbit. So we also provide systems, so the tanks, the valves, all the other peripherals that allow that engine to work. So think of us as a complete drivetrain provider. Our core IP, though, is the thrusters themselves, which are the real magic elements of the real engines. So we provide additional services in terms of launch support, propellant loading, the rest of the kit and caboodle, but the real meat and potatoes is the thrusters.
Sorry, I didn't ask the best question. What I was trying to get at is that going up already made, or is a CAD of it going up being printed in space?
So with the technology we're using, it cannot be manufactured in space. So this is stuff that we're doing terrestrially in clean rooms and then shipping to the clean room facility where it's integrated to the spacecraft and then put on the launch vehicle.
Thank you.
Thank you very much. Big round of applause. I should have moved this a long time ago. Sorry. It's your right friend. We're not using that stuff. All right. That's pretty exciting. So, one little small anecdote, right? I heard about their test fires. You sort of, everybody that's there needs to have their cars single file backed in, ready to escape in case of a problem. This sort of emphasized for me, this is for real. So, genuine rocket test fire facility in Durango, who knew, right? That's part of why we do this. Cool. Okay, one of our, just sort of mental break, a public announcement. Startup weekend, reaching back to last February, Dre stood up here and talked about from Techstars, we want to have a startup weekend. They kind of picked the days. Is Barkley around, somebody there? Barkley over there, Barkley and Aaron from Ski Locker. Yeah. If you have questions, 10th Street Co-working Ski Locker, great place to stop anyway, but they can certainly help you out. I think we're dialing in around the 8th. And since not a lot of people around here are familiar, this would be the first one in Steamboat. It happens to get a ton of people in the room, as many as you can. And anybody who wants to stands up and presents an idea for a new business. Could be fairly serious, could be completely goofy. Everybody kind of votes who they would really want to work with. You form teams over 48 hours with the help of mentors and your teamwork. You evolve that idea as far as you can. And at the end of the weekend, those companies get up and pitch to a panel of judges to see who succeeds or who kind of wins, right? And hopefully some consulting prizes, some things. All the meals are included, but it's a really super incredible event. And I want to relay one other quick story. So I mentioned what came out with Hayden and Hemp Foundry, which is great. Brian Watson shared a story for me about a startup weekend, probably closer to 7 years ago now, in Telluride. And 3 really sort of tangible, direct events happened from that affect the West Slope. One is the Proximity founders met there, a couple guys with co-working spaces that ultimately joined forces to form Proximity Space. They're in the middle of their Series A round and presented at last Steamboat launch, have hundreds of co-working spaces on their software and hardware solutions for managing co-working, like a great company on the West Slope. Might not have happened if it hadn't been for that startup weekend. Add to that, the founders of GitPrime, or those who would eventually go on to found GitPrime, met there. That was a $170 million exit recently out of Durango, software development management company. Huge exit, great returns 4.5 years in for their original investors out of scope, right? Just a great story, again, facilitated by this simple event, right? Just these sort of organic collisions. And lastly, I understand that event was fairly critical in landing the Noggers in Telluride. So I didn't see Mark Nogger. We've got some other folks from GCVF here today. But they were really instrumental in getting Telluride Angels, Tell Your Adventure Fund, Tell Your Adventure Accelerator, not only started but being successful through the years. But really one of the biggest catalyzing events for 4 Points Funding is going to the 5th graduating class of Tell Your Adventure Accelerator. It was literally on that drive home that Chris Montgomery and I were like, yeah, we're going to do this. And 6 weeks later, we had our first Steamboat launch. So we might not be here today were it not for a startup weekend some 7 years ago. So it's hard to imagine, all the threads and where those things go. But these events are really powerful, and I encourage you to support it as a sponsor, as a mentor, as a judge, as a participant. They're super, super fun. So that's my little pitch. Coming in November, and keep your eyes and ears open. So